In today's lecture, we are going to see machine learning and big data. So, we have already seen what is machine learning and what is big data. Big data is nothing but the big amount of data which is to be stored on the big data. The name itself suggests the meaning. Okay, now how this machine learning is useful to handle the big data and how the concept of machine learning came into picture, that is given over here. So the wider spread use of personal computers and wireless communication leads to big data. As we can say, in today's world, too many people uses the computers and wireless communication. I think each and every person having the personal computer and the mobile that uses the wireless communication, right? So because of this, big data came into picture, because the use of the personal computers and wireless communication, when we use the more amount of data, more amount of this resources, then there is the need to store the data, and that data is in the form of big size, so that's why we called it as a big data. So, the wider spread use of personal computers and wireless communication leads to big data. We both the producers and the consumers of this data. We only produces the data and also consumes the data, right? So the data may be random, it has certain structure, for example customer behavior. Whatever the data that we are producing and consuming, that can be random but it has certain structure, for example consumer behavior. So we need the big theory to extract that structure from the data for understanding the process, making predictions for the future. Now as we say, data is random but it has certain structure. Now that structure we have to extract from the random data. For what purpose we have to extract the structure from the data? For understanding purposes, right? Means if the random data of the if we consider the any college and whole college data is given to us, and if I want to find out only B computer students data, so that is nothing but what the structure data we have to extract from that random data, so that it will be easy to understand and making prediction for the future. Means if I want to find out the highest percentage student from the computer department, then it's very easy to find out this from the structure data. Clear? So example is recommendation system for the online store. Now next is data formats. So there are two types of data formats, that is data, we can say label data. Now what is the label data? So the data consisting of set of training examples where each example is a pair consisting of an input and a desired output value, also called the supervisory signal, labels, etc. What is the label data? Whatever the data present in the training data set. What is training data set? From the training data set, we are applying certain algorithms and we are extracting certain knowledge from that data. Okay, now this we called it as a training data set. Okay, now what is label data? So the data which has certain label given to that is nothing but the label. Label data means input and output will be input and output value will be given to that particular data, that is nothing but the label data. Clear? Like example is that If we consider the percentage of student, and if the percentage is greater than 60%, so we can call it as that student gets the first class, right? If that students having percentage greater than 60, then that students come into first class. So what is the label given to that particular data? To that student, that is first class. So likewise the label data is present. Clear what is the label data? Now next is the classification. Now classification means what? The goal is to predict the discrete values. Classification is nothing but we have to find out the discrete values. For example, 1 0, true false, spam or not spam, that we have to identify, that we have to classify the discrete values. Now what is regression then? The goal is to predict the continuous values. In classification we are predicting discrete values in the form of 1 0, true false, etc. And in the regression we are predicting continuous values, for example home prices and all. Now important elements in data learning is the data formats. Okay, now we saw what is the data, right? Now how the data formats should be stored into the training data set, that we are going to see. Okay, now in a supervised learning problem, there will always be a data set defined as a finite set of real vectors with m features each. Means in supervised learning what happened, data set contains the data, right? But it's a real vector with m features each. Means whatever the data present in the data set in supervised learning is the vector data, and each data having the m features associated with that. Clear? For example, X is the data set and there are too many data present in that data set from x1 to xn, and these are nothing but the real vectors, and each data consists of its own features. That's why where xi belongs to r raised to power m, it's given. Okay, so considering that our approach is always probabilistic, we need to consider each x as drawn from a statistical multivariate distribution T. For our purposes, it's also useful to add a very important condition upon the whole data set X. We expect all samples to be independent and identically distributed. What we have to do? We have to add one important condition on the whole data set X, so that the data is independent and identically distributed. Okay, if you apply one important condition on the whole data set, then we can identify the independent and identically distributed data. This means all variables belongs to the same distribution D, and considering an arbitrary subset of m values, it happens that. Clear? If we are having big amount of data, we have to identify in which category it belongs, then at that time this condition is useful. Clear? The corresponding output values can be both numerical continuous or categorical. In first case, if the process is called regression. If the data is numerically continuous, then regression, right? But if it is categorical, then it's classification, right? Because what happened in classification? Categorical data is given. That definition we already saw, right? So example of numerical outputs can be y is equals to y1 to yn, where yn belongs to 0, 1 and yi belongs to r plus real values, right? And this is the numerical example, that's why it belongs to 0 and 1. And what is the categorical example? yi belongs to red black means numerous values are given, or yi belongs to 0 1. Clear? We define generic regressor, a vector valued function which associates an input value to a continuous output, and generic classifier, a vector values function whose predicted output is categorical if they also depend on the internal parameter vector which determines the actual instance of the generic predictor. The approach is called parametric learning. We are defining here the generic regressor. What we are applying over here? We are considering the vector valued function. Vector valued function we are considering, which associate input values to the continuous output values, and the generic classifier. What vector valued function doing? It associating input values to the continuous output values and the generic classifier also. Clear? Now generic classifier we can say in this case as the theta. Okay. A vector values function whose predicted output is categorical. Whatever the vector function we are considering, we are associating the output to the input, right? Now in this vector valued function whose predicted outcome is categorical, जिसका predicted outcome categorical है, उसी के लिए हम लोग क्या कर रहे हैं? रिग्रेसर अप्लाई कर रहे हैं. क्लियर? If they also depend on the internal parameter vector which determines the actual instance of a generic predictor, then that approach is called the parametric learning. Clear? Where theta is the generic internal parameter vector. Clear? What we are doing over here? We are defining the generic regressor. For what purpose? For identifying the parametric learning. Clear? And what we are doing inside this? A vector valued function we are considering which associates the input value to the continuous output and the generic classifier. And what happened after that? This, if the vector valued function whose predicted outcome is categorical, then it also depends on the internal parameter vector जो डिसाइड करता है, विच डिटरमाइन करता है actual distance of the generic parameter. Clear? So that's why this approach is called the parametric learning. Now another interpretation can be expressed in terms of additive noise. Now in data, noise also present, right? So that we can consider as the additive noise, and we are adding this additive noise to this whatever this regressor we have defined. In that we are adding the additive noise also. This is also another interpretation. In unsupervised learning, now we saw the example and what is happening in the supervised learning. What happened in supervised learning? Data is labeled. And what happened in unsupervised learning? Data is not labeled. Okay. So we normally only have an input set x with the m length vector, and we define the clustering function. So what we have in unsupervised learning? We are having only the input set x and the m length vector. On that we are defining the clustering function with the following expression. Clear? With n target clusters. Okay. So kt is equals to C of x bar theta bar, where kt belongs to 0 to n. Clear? This is all about today's lecture.